In our previous lesson, we saw how we can calculate the central values of a data set that is discrete and what these central values actually mean. In this lesson, we are going to look at the measures of dispersion, also known as the measures of variability, which will help tell us how the data points are spread around the central values. The first measure of dispersion we will look at is the range, which is the interval over which the data points are spread. In our frequency table, we can find the range by subtracting the lowest score from the highest. In our example, the range is 7 minus 2, which is 5. The smaller the range is, the closer the data values are to the mean. The bigger the range gets, the further the data values are spread from the mean. However, the range only gives a preliminary idea of the spread of the values as it doesn't tell us where the cluster of most data points is. It only tells where the data values start and end. For a better idea on the spread of the data points, we also look at the quartiles. To make sense of the quartiles, let's list our data points. In our previous lesson, we found the median, the value at the center of the dataset, splitting the dataset into two halves. As the total was even, we found the median by averaging the two values at the center. Two halves in this case each have 15 data points, having each an odd number of values. Then the quartiles would in fact be the medians of each half. The lower quartile, the center of the first half, having 25% of the data set before it, and the upper quartile, the center of the second half, having 75% of the data set before it. And the difference between the upper quartile and the lower quartile is the interquartile range, which in this case is 6 minus 3, which is 3. So on my number line, we had the range of the data set, and now we have the interquartile range. The interquartile range contains around 50% of the data set. So the more area the interquartile range covers from the full range, the more values we have towards the ends of the range, as the remaining blue regions cover the other 50% of the data set. The less area the interquartile range covers from the range, the more values are clustered around the mean, as the interquartile range itself contains 50% of the dataset. In our example, we can see around 12 values out of 30 outside the interquartile range of the dataset. So the majority of the data values give a good spread of the data values towards the ends. Now, the quartiles also help us find the outliers of the dataset. Considering on the side our number line, where we mark the median quartiles found. We place boxes with lower edge at the lower quartile and the upper edge at the upper quartile and the middle edge marking the median. Then from the boxes, we take out whiskers all the way to the ends of the full range. This is what we call the box and whiskers plot. Now, to find the outliers, we use 1.5 the interquartile range. We subtract from the lower quartile 1.5 the interquartile range, which here gives negative 1.5, and we add to the upper quartile 1.5 the interquartile range, which here gives 10.5. Marking them on the number line, these are the outlier limits. Any data value outside these limits is considered an outlier of the data set and can be excluded from the study. In our example, we see that we have no outliers. Now, going back to our example, how can we find the quartiles from our frequency table? Let's bring back the cumulative frequency column. For the lower quartile, we start by dividing the total, which is 30 by 4, as 25% of the data set lie before the lower quartile. So 30 over 4 being 12.5, then the lower quartile is the 13th term. And the 13th term is between the 8th and the 15th, then the lower quartile is in fact 3. For the upper quartile, having 75% of the data set before it, we multiply the total by 3 over 4, which in this case gives 22.5. Then the upper quartile is the 23rd term of the data set. The 23rd term, which is between the 21st and the 26th, so the upper quartile in this case is a 6. Now, the last measure of dispersion we will see is the standard deviation. And the standard deviation finds the average of the distances between the data values and the mean. That is done by subtracting the mean from each data value, square these differences, and multiply each by its frequency. Add them and then divide by the total. That gives sigma squared, which is the variance of the distribution. And then finding the square root of the variance gives the standard deviation. Another way to calculate the standard deviation is by squaring each of the data values. Then multiply each by its frequency, add them, then divide by the total. Now that gives the average of the squares of the values of the data set, which when we subtract from it the square of the mean, in fact gives the variance. And then from which we deduce the standard deviation. Now, a smaller standard deviation means the majority of the data values are closer to the mean, and the interval formed by the sum and difference of the mean and the standard deviation is considered the normal interval of the data set. Now, what does that mean? Like in our example, students with scores in this interval are considered to have performed at the class level. A score higher than the upper bound of this interval are considered to have done better than the majority in the class. And the scores less than the lower bound are considered to not have done as well as the majority in the class. So the standard deviation gives a good idea of the spread of the data values that categorizes the data values with respect to the mean. Now, in our next lesson, we're going to look into group data and how it can be presented and interpreted the same way we did for discrete data.